Hello guys, in this video I'm going to continue the discussion of averaging and RMS. In the last video we take an example and we of some AC signal. It was a complex one, not so easy and straightforward. And we applied some tricks and tips to find the average value. So in that video now, we're gonna use the same tricks and tips to find the RMS value, okay, not the average value. It is basically a different definition, but basically you're gonna see while we're solving that we use the same methodology that we use to find the average. So basically, what is RMS? RMS is basically root mean square. So it's a number that represent or can represent an AC signal, a voltage or a current, for example. Okay, so we have an AC signal like a current. It's a sinusoidal wave. It's a variable with time. At zero, it's zero, and then goes up and goes down again, and so on. It's a periodic, a variant signal. Okay, so it's vary with time, but scholars, scientists want, an easy way to describe a signal like that. Okay, so they came up with the definition of root mean square. Okay, the average wasn't good because when we average a sine wave over its period, it gives you zero, because basically, the positive areas equal to the negative areas, so they cancel each other. So they came up with the root mean square. It's a definition, and they consider this like a good representation of the AC signal, like a current or a voltage. Okay, so let's write down the definition of the RMS, root mean square, and see how we can apply it to that example here. I2 of t equal to 4 sine t minus 6 sine square 5t amperes. Okay, so the definition is like, let's I2 RMS will be equal to, so I'm gonna write the integral first. It's very similar to like the average, but I'm gonna add something in the end. So 1 over t, the period of the signal I of t or I2 of t, the integral is 0 to t I2 of t. But this is till this moment it's like average, right? Now, and if we apply it, if we continue, it's going to be zero if it's a sinusoidal. So how they differentiate it, how they came up with like some modification to that function, that averaging function, so to cancel this like effect of canceling the positive areas and the negative areas. So they do the following. They square the function, so it's I2 square of t. Fine, let's even make it like so general. So let's write it in that way. Draw, and let's, for any signal, okay, let's even make it f of t. Okay, for any signal, f RMS, so f t, so they're gonna square it like that, and then take the square root of the whole function or the whole term. So I'm gonna add here very big square root. It's nicer to write it in that way. 1 over t, 0 to t, f square of t dt, then close the bracket and put half. When you raise something to an exponent of half, that basically means square root. That's if RMS. Okay, good. And then when we go forward, we're gonna find ourselves at the end of the day solving integrals. So we're gonna apply the same like tricks and tips that we applied last time when we find the averages. Okay, so let's write this down. So I2 RMS equal to 1 over t, 0 to t, I2. Let's write the definition itself. So 4 sine 10t minus 6 sine square 5t square root of all of that, I'm sorry, square all of that, t, then square root all of that like that. Okay? So what is t? Same dilemma that we have last time. If we look at the first term, omega is equal to 10. So that's the 2 pi over t, or 2 pi f, and f is 1 over t. And from that, t is equal to 2 pi over 10. Okay? But if we look at the second term, omega is 5, and from that, t is equal to 2 pi over 5. That's a contradiction, right? Right. So we need to come up with a method, trick, that either convert the 5t into 10t or the 10t to the 5t. And we apply the two solutions like last time. And of course, both was valid and correct and gives you the same answer, the same average value. If you look at the previous episode, the previous video, it was -3. So in that video, I'm going to go with the second solution only. Okay. And of course, I'm going to leave you the second one, or the first solution for you to do. It should be a very simple exercise. Okay. So what we're going to do here. So I'm going to look at, the sine square 5t and convert it into something with 10t. Okay. So let's see how we can do that. So we know that cosine theta 1 plus theta 2 is equal to cosine, sine, and minus the opposite in between. Opposite of positive is minus. So cosine theta 1, cosine theta 2, minus the opposite of that, sine theta 1, sine theta 2. Good. So cosine 10t can be written that way. It can be written as cosine 5t plus 5t, right? 5t plus 5t is 10t. So theta 1 is 5t and theta 2 is also 5t. So that gives you cosine square 5t minus sine square 5t. Okay. We have here sine square, so we need to get rid of that sine square and somehow put cosine 10t. So make it 10t all terms. So we know also that cosine square theta plus sine square theta is equal to 1. From that, sine square theta is equal to 1. Let's make it like with cosine. I'm going to show you why. So from that, cosine square theta is equal to 1 minus sine square theta. So from that, we can say that cosine square 5t equal to 1 minus sine square 5t. Theta is equal to 5t. I'm going to take that and put that here. So I'm going to remove the cosine square 5t and put 1 minus sine square 5t. So cosine 10t equal to 1 minus sine square 5t minus sine square 5t, 1 minus 2 sine square 5t. Okay, and from that, cosine 10t minus 1 equal to minus 2 sine 5t. And finally, we can say that sine square 5t equal, which is that one here, okay, equal to, we're gonna divide by minus 2. So we're gonna have half minus half cosine 10. Okay, so we're gonna go to I2 of t. We're gonna leave the first term as it is. So 4 sine 10t minus 6. Then we're gonna remove the sine square 5t and put that guy. Half minus half cosine 10t. Oh, everything now is 10t, right? So we can basically find the t capital, the period, and solve the integral. Okay, so that's equal to 4 sine t minus 3 plus, because minus is plus, 3 cosine 10. Good, 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 good. Now we go back to the integral. This one, this guy here, integral. Okay. And let's see how we can apply that. So I 2 RMS equal to the integral. So we have the big bracket 1 over t. Yes. So okay, before that, let's. Oh, I'm sorry. Is there any? Yes, yes, we're still good. We're still good. Okay, before that, we find omega. So omega here equal to 10. Okay. So 2 pi f equal to 2 pi 1 over t equal to 10. So t is equal to 2 pi over 10. Good. So I 2 RMS. Yes, I wrote it like 1 minute ago or 1 second ago or something. I small 2 RMS. This is basically, it's better to write it in a capital because the RMS value, the real definition of it, is that it's equivalent. So it is the equivalent DC current that will produce the same effect, basically the same power, okay, of that EC signal. Okay. Anyways, so you can write it like whatever you like. Okay. Equal to. Okay. We have big bracket 1 over t, 1 over 2 pi over 10. It's 10 to over 2 pi. Then another big bracket because we have like a big term right of t. So the integral 0 to t 2 pi over 10. All that guy here, all these terms, 4 terms. So we can distribute the integral over these terms. So 4 sine 10t minus integral 2 pi over 10 3 dt. Of course, there is a dt here, so let's write it minus here plus integral 0 to 2 pi over 10 3 cosine 10t. Okay. Oh, we made a mistake. That's an averaging. We forgot to square, right? So I'm gonna go back. Yeah, that's long way back. But that's good, because we can learn from our mistakes. When you solve this by yourself, the professor did something wrong here. I should avoid that. So, anyways, so okay, so we have here another bracket minus 3 plus 3 cosine 10t square dt. And close this bracket for the integrals. Then make another closure for the big bracket and put half as x1. That's basically the definition now of RMS. Okay, good. It's more complicated because we have the square root and sorry, the square root as well. So we have the square root and the square to the function itself. So let's see how to deal with that. So 10 over 2 pi, then integral 0 to 2 pi over 10, then the parentheses. So we have here 3 terms. This term and this term and this term. I'm going to consider these two as one term. Okay, and I'm going to make the squaring. So let's remind ourselves a plus b square is equal to a square, plus b square plus 2ab. Okay, so first term square 4 sine 10t square. Then I need another bracket. Very plus minus 3 plus 3 cosine 10t another square plus 2 the first multiplied by the second 2 4 sine t minus 3 plus sine 10t. Close that bracket, put the dt, put the second bracket, third bracket now, and to the power of half. That's the square root. I know it's complex, but once we continue with simplification, it's gonna be okay. So 10 over 2 pi. Okay. It's time now to distribute the integral. So we have the integral of 0 to 2 pi over 10 of 16 sine square 10t. That's the first 10. I just square everything plus 0 to pi over 10. Another bracket here, also two terms. So we're going to apply this. Okay, so AB, so A square B square to AB. Okay, so we're going to have 9 plus 9 cosine square 10t plus 2 multiplied by minus 3 multiplied by 3. So it's minus 18. Minus 18 cosine 10t. Okay, plus. And yeah, we have here these two terms. So we're going to distribute. So make it again big bracket. So 2. Then we have minus 12 sine 10t plus 12 sine t cosine 10. That's so big, I know, so big. And remember, there is another integral here, 2 pi to 10. Okay, if that's it, so close. There is no curiosity of if there is something here, we're gonna discover at the end. Okay, and we can review. That's again in AC circuits. It has like very complex calculations. Complex here has two meanings. Either we have complex values like what we see last week and the week before, or basically like very complex integrals when you solve for RMS or something. Okay. Okay, let's continue. So equal. Okay. Yeah. Okay. So 10 y 0 to y over 10, 16 sine square 10t plus 0 to y over 10, 9 dt plus 0 to y over 10, 9 cosine square 10t minus 0 to y over 10, 18 cosine 10t. That's basically these three here, that guy here. Okay. I'm gonna do the same for that one. So, okay, let's just remove these like lines to confuse ourselves. Stroke, remove. Okay, go back. Okay, equal. Oh, sorry, still continuing. So plus, yes, plus. Okay, 0 to pi over 10. Now 2 multiplied by minus 12, so minus 24 sine t. Okay, plus multiply the 2 by the 12 sine cosine. So it's gonna be 0 to pi over 10, 24 sine 10t cosine 10. Okay, that's it, I believe. We close the first bracket, we close the second bracket, and don't forget the half. Okay, so what we're gonna do is just like big, like many, like uh, terms here. The best way is to use frame mathematics. Okay, integral online calculator. Okay, it will solve your integrals in very easy way. Okay, and I like also to do it one by one. So we're gonna do this first, then that guy, third, fourth, 5, 6. Also, some of them are very easy to do, by the way, and we're gonna verify that. So let's do that together. So put that on a slide here. I put the link for that calculator in the description, so don't worry. So we have equal to 10 over 2 pi Then the first term is that one here. Okay, 16 sine squared t. 0, 2 pi over 10. Of course, this is like from the previous example. And we need 16 sine square 20. Oh, actually, we have sine square already. Okay, yeah, 16 sine square 10t. It's equal. Okay, so that's 8 pi over 5. 8 pi over 5. Okay, good. That's the first term. Yes, it should be. Okay, second one is very easy because it's basically I'm gonna do it also in the calculator, but it's very easy. So it's 9. Then the integral of dt with t and put the limits of the integral. So it's 2 pi over 10. 2 pi over 10. By the way, it's pi over 5. 2 pi over 10, it's pi over 5. Like that. Okay. But let's do it here. That's fine. So we're gonna have here 9. Oh, yeah, 9 pi over 5. 9 multiplied by 2 pi over 10, it's 9 pi over 5. The third term is 9 cosine, so 9 here. Now we can go back, I'm not sure. Yes. Okay. Cosine, yes. So cosine, fine. We might have a mistake in the first one because it was sine squared 10t. I make it, I believe, sine squared 5t. So we're gonna go back and verify that. So we're gonna put it in like a circle and we're gonna verify that. So 9, okay, 9 cosine 10t. Of course, cosine squared 10t is cosine 10t whole square. dt and 2 pi over 10. That should be correct. Okay, 9 pi over 10 plus 9 pi over 10. Okay. The third one is interesting because it should be 0. Okay, it should be because you, again, when you create a cosine over its period, we have here the negative, we have here positive areas, so they can cancel each other. But let's verify that. So we have 2 pi over 10, we have 18, and cosine 10t, and there is no square, so I'm gonna make the square 1. That basically means it's no exponent. Let's verify that. 0. Look, minus 0. Okay, good. Then we have same situation again. Sine 10t and 2 pi over 10. So again, it would be 0. So, but let's do that. That's fine. So minus 24. That's now sine, not cosine. Again, 10t dt. Okay, yes. Should be 0. Yes, it is 0. And it's right. It draws it for you, plotted for you. Negative areas, positive areas, they cancel each other. So we have plus 0. And the final term is in, which is cosine and sine. So it's positive 24 sine 10t multiplied by, I'm going to remove this like with ourselves. Cosine 10t. Okay. 2 pi over 10, 24 sine 10t cosine 10t. Oh, it is 0. Good, that's very good. So plus, okay. And it even draws for you so When you multiply sine by cosine, it will give you something like that. Something like that. And pi over 5 here, that signal here, cosine 10t, cosine sine 10t, is actually a periodic signal that just looks like a sine, but it has like double the frequency or half the period. So the period is not 2 pi over 10. It's half the period. It should be 2 pi over 20. Half 2 pi over 10, it's 2 pi over 20. Okay? And again, if you have like a period, so in 2 pi over 10, you have two periods. That's what's happening here. Okay? You don't need to understand this. You just write, just be sure that you write the equation correct and you have the integral will do it for you. Don't worry. Okay, so we finished. So let's go back, and I'm sure that's good and correct. Okay, we finished all the integrals. We close the bracket. We close also the second bracket and put the square root. Don't forget that. Equal to. Look, I'm gonna write. Yeah, we need also to verify the first because we write it, I believe, 5. Not so 16 sine squared 10t. Let's do that. Just it should be correct, I believe. Okay, but let's be sure. So shift number 6 and put 2. Okay, that to make exponents. So I believe that's correct this time. So 16. Oh, it's not 24, it's 16. 16 sine squared in t 2 pi over 10. Okay, let's 2 pi over 5, 8 pi over 5. Let's see if yes, 8 pi over 5. So we did it correct in the first time. Okay. So I'm gonna write this here as that way. I'm gonna write it 2 pi over 10. Pi over 5, it's 2 pi over 10. So 2 pi over 10. Why? Because it will be very easy to cancel out all. And here is put 2 pi. And that will be also put 2 here and put half here. Okay. So all the 2 pi's will go with each other. Then the 10s also go with each other. So you're gonna end up with 8 plus, that's the first 10, plus 9, second 10, plus 9 multiplied by half, plus 9 over 2, square root again. So IRMS equal to 8 plus 9 plus 4.5, square root of all of that. Let's use our online calculator, Demos. Okay, so I already have it, but that's fine. So 8 plus 9 plus 4.5. 4.63, I believe that's 4.63. Okay, guys, it's a bit long because we have many, integrals. Okay, again, that's the problem or the challenges that you're gonna face when you use or you solve AC circuits and finding RMS and stuff like that. So the RMS value of all that equation here is basically 4.63. Okay, what does that mean? That means the effect on a resistance that a current I2 over T passes through an AC current like that is equivalent to the effect of a DC current of 4.63 amperes passing through the same resistor. The effect here means the heat or the power consumed. Okay, guys, that was it for RMS. Thank you very much for watching and see you in another video. Bye-bye.